Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We normally share excellent questions provided by our students. Here is a very important series for those who are taking up Edexcel Level A. My student Amy will be sharing many questions and will discuss their solutions. I hope this interaction will help many of my subscribers and viewers globally.
Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good. So tell me, how are you preparing for your exams now?
So, as you know, like all the content's sort of been covered for pure mechanics and stats. So it's I guess the practice is instead of doing, those exam questions which are really topic based, try and do them all together as a whole paper because that will encompass everything. So I think, and especially doing them under time conditions, which is so important for maths. But yeah, so I'm practicing just doing papers.
That's great. That's great. So let's begin with your questions and see if I can help you. Okay.
All right.
You can share the screen. Right. So that's your first question. Can you please read the question?
So red squirrels were introduced into a large wood in Northumberland on the 1st of June 1996. Scientists counted the number of red squirrels in the wood, P, on the 1st of June each year for T years after 1996. So scientists found that over time, the number of red squirrels can be modeled by the formula P equals AB to the power of T, where A, B are constants. The line L shown in figure 1 illustrates the linear relationship between log 10 P and T over a period of 20 years. Mm-hmm. So using the information given on the graph and using the model, find an equation for L, find the initial number of red squirrels that were introduced into the wood, and a complete equation for model giving a value of B to 4SF. And on the 1st of June, there were found to be 198 red squirrels in the wood. Use this information to show that the model is not valid on the 1st of June 2019. And suggest a reason for the model not being valid at this time.
Okay, 2019. Okay. So tell me, how will you approach this question?
Oh, sorry, sir. It just moved. Okay. So with the first part, it says find an equation for L.
Yeah.
Which we want to illustrate between log 10p and t. So can we just take logs on both sides of the p equation and get it to like y equals
correct, log to the base 10. Yes, log to the base 10. So that is correct. So you can take that. So you know p is equal to a b to the power of t. And you take log to the base 10, you get log of p equals to log of a b to the power of t, which could be written as, we'll apply the log a, plus, correct. So log b, you can write t here and then again rewrite this as log of a plus t log of b, correct?
So you don't need to write the 10, do you? Even though they've given it log 10p.
No, it is default. Okay. You need not write. They have given, of course. In your marking scheme, you could check that, but check with your teacher also. It is not required. That's the default. Yeah. Right? So you do get log p as this, right? So let's write linear relationship between log of p and t over 20 years. So it's linear in a way that log of a is a constant, right? So if you compare this with the y equals to mx plus b, so you can see that the slope or the gradient m is equal to t, right?
T, yeah.
Log b, sorry. Log b is the
t
gradient.
Is x.
T is the variable, right? So I could rewrite this equation as log p equals to t log b plus the y-intercept, which is log a. Is that okay? So from here, log a is 2. Do you see that?
Yeah.
So log a is equal to 2. That is a y-intercept, right? So that is how you could interpret. So this is a linear equation where log a is a y-intercept, a constant, And the gradient is log b, and t is your independent variable as shown in the diagram.
Yeah.
Correct. Now, find the equation for L. You've done that. Then find the initial number of red squirrels that were introduced into the wood. So log A is equal to
2.
So A equals to 10 to the power of 2, which is
Squared.
100.
Yeah.
So, yes.
So do you need more room? Do you want me to?
Okay, so we can continue. Yeah, that is better. But what is the next question?
Find a complete equation for the model, giving the value of b to 4SF. So value of b, can't we just sub in this 20 to
Gradient.
24?
Yeah, the gradient, right? So this is 2.420, right? So the value of b is the gradient, as you can see.
22.4, yeah.
So log of b is basically equal to 2.4 minus 2, y2 minus y1 divided by x2 minus x1. So 2.4 minus 2 over 20 minus 0. So which is 0.4 over 20. So b is equals to 0.4 over 20. Let me write 0.4 over 20. All right, to the power of 10. I mean,
50, so b equals,
write this as. Let's simplify this, right? So this is 4 over 200, right? So 1 over 50, correct?
1 over 50, yeah.
So b
I
will
just
be
did that.
10 to the power of 1 over 50.
Yeah, just did on my calculator. So 1.047 to 4SF, I think they said. Yeah.
4 significant 1.04.
047. Yeah.
Great. Next question.
So part D, on the 1st of June 2019, there were found to be 190 red squirrels in the wood. Use this information that the model is not valid on the 1st of June 2019.
Okay. So 2019 means how many years? So because T is number of years since 1996, right?
23.
So 23. So plug in 23 for T in your equation. You know value of A and B now, right?
Yeah, we do.
Yeah, you could use otherwise the same equation.
So it says not valid.
Yeah,
On
so
the
you
first
get
of
a
June.
result which is not 198, right? So it
Okay,
says
so
on 1st of June, they were found 198 red squirrels. So what answer you're going to get will be different. So this is not
okay.
valid. That is what they're
So you will do log p. So we wouldn't put, we were just trying to find log p equals 23 times log b, which was the 1.047,
right.
plus the log a, which a was 100. Like that?
Yes.
Oh, okay. 10 to the power of. What's that? Oh, it's because the calculator doesn't automatically put the 10 there. So it's really annoying. Plus log of 100. So I'm getting 123 over 50 for log p. So p has to be 10 to the power of that.
Okay. How much you get?
288.
So not 198. So 288 is 100 more, very high value, right? So that now you have to provide a reason why this is not valid, right? That is the reason you have to provide. So why do you think for how many years it was?
23.
24.
Just pass the graph.
For 23 years, it was not valid. So any reason you could figure out from the equation itself?
Now, here is, after the discussion with Amy, here is how we actually solved this particular question. We were given that the red squirrel population can be modeled by the function p equals to a times b to the power of t, where t is time in years since 1st of June 1996. First part of this equation, what we need to do is to find the equation of the line which is given on this graph where we are plotting log to the base 10 of p with time. So to get this equation, there are a couple of ways. One, of course, we can take logarithms on both the sides, and in that case, we get log to the base 10, of course. I'm not writing 10 since that is the default value, equals to log a b to the power of t. Now here we can apply the rule. This could be written as log to the base 10 of a plus t times log to the base 10 of b. Now you can clearly see that is kind of an equation of a line, right? In the form y equals to mx plus b, where the slope m is basically log b, right? T is your independent variable and the y-intercept is log of a. You get the idea. And therefore, we can write down the equation of this line very easily in terms of the parameters we just figured out. So, let me rearrange and write down log of p equals to log b times t plus log of a. You get the idea. So that is the way to write down the equation, where we know that the gradient m is equals to log to the base 10 of b and the y-intercept b is log of a. Now that helps us to find the value of a and b from the given graph, correct? Let's look into this graph once again. As you can see here, the y-intercept is 2, right? So what was the y-intercept? This 2, which is the log of a, gives us the y-intercept. And from here, we can say 10 to the power of 2 is a, or the value of a is 100. So that gives you the initial population of the red squirrel introduced in the woods, correct? Now, we can also find the gradient. Gradient is basically y2 minus y1 over x2 minus x1. And from here, we can take up the values, which is 2.4 minus 2 over 20 minus 0. So that is the gradient. And gradient we figured out just now as log of b. So equating this to log of b, which is 0.4 over 20, or dividing we get 0.02, we can find the value of b. And the value of b will be 10 to the power of 0.02. Using calculator, we can find this answer. You get the idea. And once we find the value of a and b, we have all our equations. Perfect. So that is how we are going to tackle this particular question. Here is a neat solution for you, step by step. Just as I explained, we are given the function p equals to a b to the power of t. Linearization of exponential functions, as we have done here, helps us to interpolate and extrapolate, and that is the importance of this. We need to find the equation of this particular line shown in the form of y equals to mt plus b, where m is the gradient, b is the y-intercept. We can take log to the base 10 on both the sides. We get log p equals to log of ab to the power of t, and doing these calculations, what I just shown, We know that the y-intercept will be log a, which is 2. And so a is 100, 10 to the power of 2. The gradient, we calculated b as 10 to the power of 0.02, which gives you 1.047 to 4 significant figures, right? So that gives us the equation. So we could write the equation in logarithmic form and also in exponential form. In the log form, the equation will be log p equals to 0.02t plus 2. And in exponential form, the same equation can be written as p, the population of red squirrel, equals to 100, the initially introduced, times 1.047 to the power of t, rate at which their numbers is increasing, is 1.047. And second part of this question was to find the population after 23 years. You can see that this graph is given to you for 20 years, 0 to 20, right? Now after this, once we extrapolate and use our equation, we get the population as 100 times 1.047 to the power of 23, which gives us 288. However, in the question, it is given that the actual population counted was only 198, not 288 as we calculated. So part B of this question is, what could be the reason for the value to be much lower than what is expected by the model? Or you can also say why the model doesn't fit the situation after 20 years. Now, since the actual recorded is much lower than what we calculated, it means something drastic must have happened. Now, the reasons could be maybe increased population of the predators, which kind of controlled the population, or it could depend on the sustainability of the woods themselves. After all, it is confined in resources, and therefore the population will have a limiting factor. So, woods may be or may not be able to sustain that larger population of the red squirrels. Well, the other possible reasons could be disease, they were introduced into this new habitat, so that could be another reason. Or the loss of habitat, right, over a period of time. Or there could be unexpected change in weather that can also lead to drastic reduction of the expected number of red squirrel in this forest. So I hope with this you have understood how do we explain and solve such questions, right? Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. In this series, we are going to discuss many questions from past papers and provide your suggestions if that really helps you. Thank you and all the best.